This video is about identifying the method which will be best to solve a system and explaining our reasoning and solve a system of linear equations and summarize our meaning. So all of these systems of equations there are going to deal with mixing solutions together to make a new solution. So a chemist needs to make 36 ounces of a 12% solution by mixing together an 8% solution and a 17% solution. How much of each solution should she use? So the two solutions that we're mixing together are going to be represent our x and y. So we're mixing together the 8% and the 17%. So x is going to equal our 8% solution, and 17 is going to represent, y is going to represent our 17% solution. So what we're going to do with this is we're going to make a table that's a 3 by 3. And in the first column, we're going to do ounces. So for the ounces, we know that we need to mix a certain number of x and a certain number of y to make a total of 36 ounces. Then in our table, we're going to, in the next one, have our percentages. So we know that the x has an 8% solution, the y has a 17% solution, and we're trying to make a 12% solution. So that's going to go in the last box. To get our last row, which is the total, we're going to multiply across to get our boxes. So we have 8 times x, which is 8x. We have 17 times y, which is 17y. And we have 12 times 36, which is 432. So we're going to use the first column and the second column as our system of equations. So we have x plus y equals 36, and we have 8x plus 17y equals 432. So now we can decide which method to use. I'm going to use elimination. So in order to use elimination, I'm going to multiply the first equation by -8 so that my x's can cancel out. So I have -8x minus 8y equals -228. And then I have 8x plus 17y equals 432. So when I add straight down, the x's cancel out, and I am left with 9y equals 144. When I divide, y is 16. Once we know y is 16, we need to go back and get our other variables. So I'm going to sub 16 in for y. So I have x plus 16 equals 36. We can subtract 16 from both sides, so x is 20. So our ordered pair then is going to be 20, 16, which means the chemist needs 20 ounces, which we can abbreviate as OZ, of the 8% solution and 16 ounces of the 17% solution. So let's look at another example. Number 2, the same chemist needs to mix together another solution. This time, she needs to make 40 ounces of a 23 solution by mixing a 17 and a 25 solution. How much of each solution does she need? So again, we're going to make a chart after we identify our variable. So our x is going to be the lower percentage, so 17% solution. And we're mixing it together with the highest percentage, which is 25% solution. So when I make my table, we're again making ounces. So our first column is going to be our ounces. We don't know how much x, we don't know how much y, but we know together it's going to be 40 ounces. Then we do our percent. So x has 17%, y has 25%, and our new solution will have a 23% solution. So now we can multiply across. So x times 17 is 17x, 25 times y is 25y, and 40 times 23 is 920. So again, we're going to use the first column and the second column to solve for x and y. So we have x plus y equals 40, and we have 17x plus 25y equals 920. So this time I'm going to decide to eliminate my y's. So in order to cancel out with a 25, I need to multiply by negative 25. So I get negative 25x minus 25y equals negative 1,000, and 17x plus 25y equals 920. So when I add straight down, I get negative 8x, the y's cancel out, equals negative 80. So to get x, I would divide, I get x is 10, and then I need to go back and get my other variable. So I'm going to substitute 10 in for x. So I have 10 plus y equals 40, which means y is 30. So my answer would be 1030, which means the chemist needs 10 ounces of 17% solution and 30 ounces of 25% solution. So let's look at one more example. Tucker is performing a science experiment in class where he needs a 33% sodium chloride solution and a 9%, where he has a 33% sodium chloride solution and a 9% sodium chloride solution. He needs to make 60 ounces of 21% solution. How much of each solution does he need? So the two solutions that he's mixing again are going to be our XY. So the X is going to be, we can do it in any order, so I'll just say the one that was listed first, 33%. We'll just call them solutions instead of writing out sodium chloride. And Y is a 9% solution. So again, we can make our table with our 3 columns and our 3 rows. So in the first box, we're going to have our ounces. So we know that we have an X ounce, a Y ounce, and he's making a total of 60 ounces. Then we know that the X has a 33% solution, the Y has a 9% solution, and he needs to make a 21% solution. So we can multiply across 33X, 9Y, and then 60 times 21, which is 1,260. So now we have our two equations. So we have X plus Y equals 60, which is that first column, and the last column, 33X plus 9Y equals 1,260. So this time I'm going to decide to eliminate my Y's by multiplying by negative 9. So I get negative 9 minus 9Y equals negative 540. And then I have 33X plus 9Y equals 1,260. When I add straight down, negative 9 plus 33 is 24x. The y's cancel out, and this is equal to 720. So when I divide by 24, x is 30. So if I know that x is 30, I'm going to substitute that in to my equation to get y. So 30 plus y equals 60, which means y is also 30. So our solution would be 30, 30, which means Tucker needs 30 ounces of 33% solution and 30 ounces of 9% solution.